Hello! So I'm using a new camera today just to kind of see what that looks like. The image of the camera is much better than the little webcam that I was using before, but it's very high because the tripod that I have isn't quite right. So we'll see how this works, although I'll probably try repositioning it later. Anyway, yeah, I'm going to read another Quora question today. This one I kind of referenced in other videos when I was talking about breaking down problems into smaller pieces that are actually like digestible. So yeah, we'll read through it and call it good. What is the biggest secret in computer science? What is it, and why do people keep it a secret from beginners who want to get into computer programming as early as possible? The first thing I would say is this guy seems to have like a very confrontational relationship with older engineers, maybe. This is a rough tone for the question to take. Like everyone else is in on a secret, but not this guy because nobody will tell him. Kind of like a old boys club where really there isn't any. The biggest secret in computer science, or at least in programming, is not a secret at all, or at least it is a very open secret. People in the know repeat it all the time. Learning to program is not about learning a programming language. It is about learning to think. To program, you need to understand the problem deeply enough that you can reduce it to mechanical steps that take no thought. That's it. That's programming. It's not learning C++, nor Python, nor Haskell, nor Rust, nor SQL, nor Prolog, nor assembly language. None of those things. It's about learning how to turn some problem into steps that are so simple, so mechanical, so well understood that you can write them out in one of those languages or some other language that makes all the details clear. And if you read my extended discussion with Comet in the Space AI Emergency about whether LLMs, large language models, are programmed or not, you will see that's the crux of my argument and why training is not programming. They haven't made the knowledge in the training set mechanical, well understood. They may have made the neural net have those characteristics, but the training data not, at least in the cases I have seen. But many people refuse to understand that, the need for a mechanically precise understanding of what the machine should do to program the machine. They think when they have a vague idea of how something works, that's good enough. And it may be for communicating to another sentient being, thing, object, that has a similar level of understanding and can fill in the missing pieces. This is long, but that isn't programming. It might be coding. You can sometimes code a computer program that seems to do what you want without that understanding. The missing pieces in your understanding might just happen to match a model that is implicitly expressed in your coding. People do that all the time. They get a program that happens to work for the cases they have seen the happy path. If they get lucky, the happy path is close enough to being right that it works for all the cases the program will ever see. But if you actually want to be a programmer, you won't stop with something that seems to work. You will understand why it works. You will have an actual model of what the problem is. You will understand that model. You will know its limits, where the boundaries are that the model is likely to stop working. And that is often hard. Moreover, sometimes your model will be wrong and you will think you have programmed something, but you haven't. Even after 50 years of doing so, I still find that to be true from time to time. I will have made an untrue assumption in my model and the program won't work. I also know how to go back and figure out where my mistake in reasoning was, what I assumed that was wrong. Then I can fix the program because I will have a better understanding, a better, more complete model. Edit added. That's, oh my God, there's so much here. I'll read it all. That's not the only secret about CS and programming that is obvious to people in the field, but to people wanting to get into it isn't obvious, and even when told, they refuse to believe. The fact is, to be a good programmer, it takes years of practice, even if you have a natural aptitude, and bad programmers, of which there are an overabundance, actually make more work by creating programs that are security holes or don't function properly, or have a host of undesirable properties. The ease of coding programs that work for the happy path hides from many people the fact that there are other paths through the program that they didn't think about which cause it to malfunction in numerous ways. Or, what did James Gosling mean when he said, "I don't think anybody tests enough of anything"? Getting a simple program to work for a few cases is easy. Doing the work to make production quality software is surprisingly hard, and you cannot learn to do that in 21 days. You are just barely ready to learn how to do that when you have written programs for 4 years, even if you have a relevant degree. Many, I would even say most, don't ever really master that skill. I've been programming for 50 years and I can only do it within a limited scope. I know that from bitter experience of trying to do it outside that scope and failing. There's a lot I could talk about inside of that. I had read this question quite a while ago and I hadn't really thought of programming this way exactly. That's not true. I've known for a long time that the part that a lot of people get confused with programming is just writing the code out. But the actual hard part of programming is designing a large system. One thing that is really interesting about this problem is working in avionics, we have to test everything using really, really intensive test frameworks. So we do often have tests that hit every single branch of code. So there's different design assurance levels is what they're called, DAL levels. And DAL A is the highest priority DAL level. There's A through E. A is if the code fails to do what it's supposed to do, catastrophic failure could result in the loss of life, like the airplane could crash. So DAL A code gets phenomenal testing against it at multiple layers, making sure that the requirements are complete and that they do everything that they're supposed to do. And that's where I spent a lot of my time, was actually testing code that it needs to be DAL A. That's one of the things I started with. And what's funny about this question is it shows how useful that may have been in my ability to become a competent engineer. When you know that you have to go through every branch of code with testing, you start to look at the way that you write branches of code very differently. You go, does this branch need to be here? And how am I going to recover if I do put a branch here? Should I just hard error out? You start thinking of all of the unhealthy cases that this guy is talking about. So yeah, I don't want to talk too long about this one. I want to keep this video pretty short, even though I think this is really interesting. So that's all I'll say for it. I'll edit it down and see how this new camera looks. Hopefully it looks okay. I think I'm also going to try blocking out the text as I read through it, making it to where it's fuzzy until I'm to that paragraph, just to see how hard that is to do in Adobe, or in Premiere rather. All right, thanks. Bye.